now for the next step, let's try to do a mapping on a 3D object. So I'll create a new project for that. Call it 3D mapping project. We start again from an empty scene, and now when we add screen, instead of selecting one of the generic like flat, dome, cylinder, etc., we will select a custom 3D model. From here, we can import an OBJ and FBX, so I can import it from my local storage on my computer, or if I already imported a model, then I can reuse it again, which is practical when you have certain models or textures or assets in general that you use often, that they are stored on our platform, on your profile, and that you can reuse them. So I will use the Reimturm FBX. This is a model of the tower in Düsseldorf. So when we import the model, oh, maybe that was too quick. Let me do it again. So add a 3D model, and then I select the tower. And here, when we select a model, a lot of you might know it, the pain of when you import a 3D model and you have no idea how big it is, where it ends up in the scene, how it's oriented. So you just see that it's there in the scene, but you can't actually see it. With that, we created a 3D model helper that automatically, when you import, you get prompts to look at the 3D model you imported and see the bounding box measurement of that object, so how big it is. And you can apply basic transformers before it actually goes to the scene. For example, source unit, we can define that to millimeters. You can also do a custom scale, foot, inch, etc. And we see that reflecting. Also useful to put a reference human on a reference 1x1 meter cube. So you see compared to your object, what scale are we preparing. Same with using different software, Blender, SketchUp, Maya, etc. Sometimes Z is up, X is up, depending on your model. The origin also, you want to offset it to the center or to the bottom center. This one is clamped to the bottom. You can edit the pivot point manually of the object to define where the 0 is. So we want the 0 on the ground or the 0 as is coming from the 3D model. So things like this. In my case, I scaled now to millimeter. I end up with a tower that is 24 meter long. And this is a 0:1 scale. In real life, the tower is 240 meters. And for the planning, I will plan to a 0:1 scale. So 24 meters for me is good. Then I apply and I get my tower in the scene. This also you can access again in case you imported wrong. You go to the 3D model, check in the parameters, and then you can open the helper and scale it again. So once that is done, we will start by adding projectors again. So this is an outdoor projection on a tower. So we would want something at least 20,000 lumen. So then we get the list when I filter by 20,000 lumen here. So we get Barco, Christie, VVTech, etc. Let's pick, for example, Barco and UDX U40. This gives us 38,000 lumens. So pick this one. Then I move it in the scene. That's my first projector. And here again, I don't have a reference of the space. I don't have a drawing. It's not a room, so I can pick a reference from Google Maps. So I'll just go to Google Maps. I know this tower. It's our lovely tower in Düsseldorf that we map on quite often. So I can find it quickly on Google Maps, take a screenshot, and then import that. So let's say something like this. Take a screenshot. Tool here. And then I'll save it. Item. Then back to the tool. Then I can import a reference drawing, import new, and here I have my PNG that I saved as a screenshot. Import that in. And when I took the screenshot, I was careful to get also the scale from Google Maps. So we have it here as a reference. This line is 50 meters. So I select this, snap here, and in my case, it is 5 because I'm working with a 1 to 10 scale. Create reference. And now we have the geographic data. So I will roughly place the tower somewhere here. Something like this. And then I can start placing my projectors where I want them to be. So depending how the drawing is oriented on the 3D model, then we would go, for example, we know we have this parking space where we are allowed to put the projectors. So we would start mapping from there. Or in our case, we always have the roof of this building, the land tag that we have access to, there where we can put projectors. So I can start planning this way. So here we go. For the projector, I will switch the lens. Let's try 1.23 lens. And I'm about 10 meters from the floor. So here with my Y scale to 1 to match the roof. Since it's a tower that it goes more vertical, here it's interesting to put the projector in portrait so that we don't lose resolution and we can cover from the image as much as we can. So do that. Pivot the projector up, and then for the rest, use lens shift to center it a bit. And I can call this one bottom projector. And then we can duplicate this projector, move slightly next to it, so we stack them side by side. Pitch this one up. Then we start noticing that at this distance, the further you go from the object, so the more the screen is further, the image gets bigger, of course. So we need to get a longer lens. So I'll go with a 1.6 and then go with the yaw back down. (78 to 227), something like this. So we get an overlap. And we can clone this again to get the third projector. Side. Up. Some vertical lens shift to center. Same with the other one. Vertical lens shift to center. Image. Then horizontal shift up and down. Here on the top of the tower, we have the shape that opens, which makes it interesting to put another projector in the landscape to cover that. But first, we can stop at this and start analyzing what we have. So first thing we can do is we can do a quick brightness analysis. And we can notice already the projector on the top is darker. So it gives us a redder tint on the heat map. And on the bottom here, it is darker on the surface and brighter in the areas where it's touching the grass and the entrance. So we have actually margin to push the projector up. And on the top projector, we should either do a stacking or add another projector in landscape, etc., to improve the coverage. So this one up. Steps. And with this one, let's say I still want a longer lens, so I'll go and create myself another lens. So here, I'll call it long lens. And I'll do this one from 5 to 10. Lens shift is the same, so I can apply it. I can apply it to all projector in the group, and I can also save this projector to my library. So I will do that. save it to my library, and I'll call it Barco UGX with long custom. Save. Apply. And now on this one, getting a very uneven pixel size distribution here to show you how wild you can make the planning. So this is with the long lens, this is with the short lens, and then we homogenize it, remove this projector, for example, you clone the other one to do more coverage, etc., etc. Let me get this to back to the other lens. And since I saved now the projector to my custom library, I want to show you where that ends up. So when I add a new projector, I can either select from the projector database. These are about 650 projectors. They are coming from the manufacturer data. And I have also my projectors. And these are projectors that I saved on my own by choosing their own list of lenses, choosing also the resolution, brightness, etc. And I have here my Barco UDX custom, for example. So what else here we want to do? So with the planning, let me make it a bit more uniform. So we take the first projector, longer lens, cover down. Down. Center shift. Up on the other projector, go on with the longer lens, and down to here. So let's say we will cover this portion. And then horizontal shift. So here. So I can mute my reference drawing here. So I can go and look on this side. Then I can analyze the brightness again. You see it's better, but we still lack brightness on the top. So that's why we would need a stack. You can also account for blending. Here we can do a custom scale for our brightness to see more the nuances. So if we cap this to a 0 to 300, for example, the range, and we regenerate the graph, then we get the heat map matching that nuance. I'll show this also a bit later, how to customize the analysis and create reports out of it. But at this step, let's say we want to add a camera to see if we can analyze the screen and calibrate it. Because we have VIOSO, we calibrate always projectors with a camera. So let's add one of the model cameras. For example, this is the CK76, 76-degree camera. Orienting it in the scene. And then I can view through the lens of the camera. So I'll place it here next to my projectors in our area. Put the drawing back again. Then I can orient the camera up. Then look if I can cover the entire surface with one single camera, or if I'll need multiple cameras, or maybe a camera with a wider lens. Something like this. I can also enable the frustum of the camera to be longer, in 20 meters, and then I can see if my camera covers this shape or not. Same, by the way, for projectors. So we can here make the frustum, so the rays of light, bigger, and we can see how the projectors overlap. Select also.
We have already multiple questions if you can calculate the overlap and stuff like this, Ahmed. So maybe it's a good time also to go into analysis at a certain point.
That's a good point. So the overlap here to check the coverage. So we have an overlap analysis where we can see at least the outlines of the projectors, and we do a hashing for areas that are overlapped. And from this, we know what is our overlap. Here, average overlap is 4.9%, but this is wrong in this case. It's because we're not mapping the whole tower. So it's a bug. And we see the screen coverage, so how many of the screen we are covering. Usually, you would import a model like this for doing rough estimations, and then when you try to do the real mapping, you will import the portion that you actually map, and that is UV unwrapped also, where you can preview content. So I will import. I'll import that. So I have it here. I can mute the other one, and then this is the portion of the tower that we are actually interested to map. So only 180 degree, and the top part, which is a restaurant with glass, we are not interested in. So on this one, we can do better analysis here. And we can check also the brightness again. But most importantly, we can check the warp and blend, and we can preview how our content will be. For example, this part that is not covered. So I can import a custom grid. For example, you have some template content for the 3D model. And then I can preview a technical test pattern for the content, or even videos and pictures. Let's see if I have some videos, yeah, like kaleidoscope video. No, this is a custom texture video. Then I'll need to load it as a screen texture. So let me mute the projectors, and I'll load it here. So yeah, like a kaleidoscope effect. Then you can preview content, how the mapping will be. We can also do that per projector. So if I remove the tower here, enable this again, enable my projectors. So I can select one projector, and instead of the green pattern, for example, this one, I could switch the content type to custom image or custom video. And I can play a texture, for example, here, abstract contour. And then I have that per projector, how the animation would look like on the image. I guess from a 3D model projection mapping, this is more or less the workflow. I will now create another template project where we do an immersive room and continue to explore more features of the software. We still have a couple of analysis points to check, and reporting, exporting, etc.